Assalamualaikum students. Now in our last topic we have read the impedance of LCR circuit and that comes out to be Z equals to V over I equals to under root of R square plus XL minus times XC whole square. What is the impedance? Impedance is the effective opposition of to the flow of charge by LCR circuit. Or you can calculate there I also we already the calculated. Now let us do one thing. Let's now calculate. We will say let phi is the angle. Let phi is the phase angle. Let phi be phase angle. Phase angle between the net voltage now V and the current through LCR circuit. Then we will have tan of phi. Tan, that is the perpendicular base, that is VL minus VC over base, that is VR. Now instead of VL we are having IXL minus times it is IXC over IR. Now I and I is going to get common, then it gets cancelled with this I, and what we'll get tan of phi equals to XL minus XC over R. R equals to XL itself is L omega minus some XC itself is 1 over C omega over R. Now this is tan of phi, that is the phi, where phi is the phase different. So if I will say if current in circuit is I equals to I naught sine of omega t, then V voltage will be V naught sine of omega t plus of phi, and that phi comes out to be from here. You have to use the value of phi here. So now what we'll do, we will use here now special cases. Now in special cases, if we are having XL equals to XC, then this will term vanishes. Once it will vanish, it will 0 by R, then it is 0. Then tan of, if I will say especially if XL equals to XC, then tan of phi equals to 0, which implies phi equals to 0 because tan 0 is 0. That is no phase difference between current and potential, current and voltage. Then we can say in that very case that is a pure resistor circuit. Then if you will see a bit this very equation at that very time, once this equals to this totally vanishes, the square and root will cancel, then simply z is equal to r. Then at that very time, then z equals to r, pure resistive circuit. Now there can be the second case. What will be the second case? The second case will be once when XL will be greater than XC. When XL will be greater than XC, then tan of phi equals to positive. Once tan of phi is equal to positive, that means phi equals to positive. Once phi is positive, that is V leads current by angle of phi. Such an circuit is called as inductive dominating circuit. Such circuit is inductive dominating circuit. Similarly, you can have the third one when XL less than XC, then tan of phi equals to negative of phi equals to negative, then you have to say then it is current, it is current which leads the voltage. Hence capacitive dominating circuit. So you have to remember from LCR circuit what can we conclude? We can simply conclude that uh, we can have inductive dominating circuit, we can have pure resistive circuit, we can have pure capacitive circuit. Sometimes it is asked in the well exams that when the LCR circuit behaves as pure resistive circuit, that is only when inductive reactance and capacitive reactance become equal. This is all for today. Tomorrow we'll with another lecture. Till then, Allah Hafiz.